Namaskar everyone, my name is Navin Yadav and I am faculty of physics at Rawat Public School. Now in today's video, we will be learning about magnetic field inside a solenoid. Okay, so our topic is to calculate magnetic field inside a long solenoid. This is our topic for today's video. Now, for this topic, let us understand what is a solenoid. A solenoid is simply a cylindrical tube or which copper wires are wounded. So this is a solenoid. Okay. Now in these copper wires, a electric current is flowing. Let's suppose that electric current is I. This is entering from this side and it is leaving from this side. Okay. Now when we wound these copper conducting wires, then what happens? This whole arrangement becomes a solenoid, and one of the terminal will behave as north pole and the second terminal behave as south pole. Okay, so we can say that this is a solenoid. Now, for finding the magnetic field of this solenoid, we will be using a simple concept, that is a law, that is Ampere's circuital law. Ampere's circuital law. Now, what this Ampere circuital law? This is very important and very necessary for most of the derivation for magnetic field. So let us understand what is that Ampere circuital law. Now, this law states that close integration of magnetic field B dot dl over a length is equals to mu naught times the total current threading through that closed surface. Okay, now understand this. This is a closed integration. For closed integration, we are putting here a symbol. It is saying that it is a closed integration of magnetic field over a length is equals to mu naught times the total current threading through the surface. So here the current I is flowing and mu naught is the permeability of the medium. Okay, so this is the law that we will be using for finding out the magnetic field because of this solenoid. Okay, so let us derive the equation for magnetic field. For calculating the magnetic field, we will be taking a rectangle and let's say name of these parts A, B, C, D. This is a rectangle that we are taking. We are finding magnetic field because of this solenoid. Okay. Now, according to Ampere's circuital law, closed integration of magnetic field over the length is equals to mu naught I. This is the law, and we will be taking it for A, B, C, D. So B is a magnetic field, so let us take them small. This is A, small b, small c and small d. Okay. Now, length of this rectangle is L. The length of this rectangle. So, instead of computing magnetic field for entire this rectangle, we will be dividing the whole rectangle in different parts, different segments. So, this is from A to B, B dot dl plus integration of B to C, or with this we will be adding a term that is cos theta, B dl cos theta plus integration B to C, B dot dl cos theta. Okay, plus integration C to D, B dot dl cos theta plus b to a cos theta is equals to mu naught I. Now here you can see AB is parallel, that is making angle 0 degree with this solenoid or this magnetic field. So we can write this as A B B dot dl cos 0 plus B to C B dot dl cos 90 plus C to D B dot dl CD again 0 degree angle, it is parallel, plus DA B dot dl, you can see it is making 90 degree angle, so it is cos 90 is equals to mu naught I. Okay, now cos 0 is 1, this cos 90 is 0. All the terms in which cos 90 is present, so they can be written as 0. I am writing here the next part, integration of a dot b, integration a to b, b dot dl, because cos 0 is 1, it is 1, cos 90 is 0, it is 1, it is 0. So we will be writing this plus it is 0, because cos 90 is 0. Anything multiplied with 0 gets eliminated. So it is again 0. Now next is b dot del cos 0. Cos 0 is 1 obviously. But CD, where it CD? CD is here. It is outside this solenoid. So there is no magnetic field in this region. So it is again 0 plus cos 90. So it is 0. So we need to write it as 0 and it is equals to mu naught I. Okay. Now I am erasing this thing. Now see, integration of b dot dl. B is constant, so we can take it out. Integration of dl is equals to mu naught I. Integration of this dl, that small length. So entire length we will be taking it as b dot l is equals to mu naught I. So it is b is equals to mu naught I divided by l. This is for one term only. Okay, this is for one term, and there are n number of terms. For n terms, we can write down it as b is equals to mu naught n I divided by l, and again we can write it as b is equals to mu naught I, and this is n, where this small n is equals to number of turns per unit length. So total magnetic field inside this solenoid is b is equals to mu naught n I. Now you can see it is independent of the length of this solenoid. Okay, it depends only upon the amount of current which is flowing into this solenoid. Okay, so this is the magnetic field because of the solenoid. Now in the next video we will be seeing about magnetic field produced by a torrent. Thank you very much.